Python. Python was created in 1991 by Guido van Rossum, a Dutch programmer who wanted to make coding easier and more readable. Unlike many programming languages that use complex syntax, Python focuses on simplicity with clean code that almost looks like plain English. This beginner-friendly approach made it one of the most popular languages in the world, especially for people just starting their programming journey. What makes Python stand out is its versatility. It's widely used in data science, machine learning, web development, and automation. Companies like Google, Netflix, and NASA use Python for everything, from analyzing massive datasets to powering recommendation algorithms. Python also has a massive library ecosystem with tools like NumPy, Pandas, and TensorFlow, which allow developers to build powerful applications without writing everything from scratch. However, Python has some weaknesses as well. Since it's an interpreted language, Python tends to run slower than languages like C or Java, making it less ideal for performance-critical applications like game engines or operating systems. It also consumes more memory compared to other languages, which can be problematic in resource-constrained environments. But despite these limitations, Python remains the go-to language for data scientists, AI researchers, and beginners alike. C is one of the oldest and most influential programming languages ever created. It was developed in 1972 by Dennis Ritchie at Bell Labs as a system programming language. Originally designed to build the Unix operating system, C quickly became the foundation for modern computing. In fact, many operating systems, including Windows and Linux, are written in C, and it continues to be the backbone of low-level programming. What makes C powerful is its speed and control over hardware. Unlike high-level languages, C gives programmers direct access to memory through pointers, allowing for highly optimized and efficient code. This is why C is still widely used in embedded systems, operating systems, and performance-critical applications like game engines and real-time systems. It's also the foundation for many other languages, including C++ and even Python itself, which is implemented in C. But C comes with challenges as well. Since it requires manual memory management, developers must allocate and free memory themselves, which can lead to bugs like memory leaks and buffer overflows. These issues can cause crashes or security vulnerabilities if not handled carefully. Additionally, C lacks modern features like object-oriented programming and automatic garbage collection, making it harder to write large-scale applications. Despite these drawbacks, C remains essential for understanding how computers work at a fundamental level. C++. C++ was created in 1983 by Bjarne Stroustrup as an extension of C, adding object-oriented programming features while keeping its speed and efficiency. The result was a language that combined low-level control with high-level abstractions, making it perfect for building complex software systems. Over the years, C++ became the language of choice for performance-intensive applications. What makes C++ powerful is its flexibility and performance. It's widely used in game development, with engines like Unreal Engine relying heavily on C++. It's also the backbone of operating systems, browsers like Chrome and Firefox, and even financial trading systems where milliseconds matter. C++ supports both procedural and object-oriented programming, giving developers freedom to choose the best approach. Additionally, features like templates and the standard template library make it easier to write reusable code. However, C++ is notoriously difficult to learn and master. Its syntax is complex, and it inherits many of C's challenges, including manual memory management. Modern C++ has introduced smart pointers to help with memory safety, but the language still requires careful attention to avoid bugs. Compilation times can also be slow for large projects, and debugging can be frustrating, especially for beginners. But for developers who need maximum performance, C++ remains an essential tool. Java. Java was introduced in 1995 by Sun Microsystems, led by James Gosling, with a simple philosophy: write once, run anywhere. This meant that Java code could run on any device or operating system as long as it had a Java virtual machine installed. This portability made Java incredibly popular, especially for enterprise applications and Android app development. What makes Java stand out is its reliability and widespread use. Java is the primary language for Android development, powering millions of mobile apps worldwide. It's also heavily used in large-scale enterprise systems, banking applications, and web servers. Java's automatic garbage collection handles memory management, reducing the risk of memory leaks. Additionally, Java has a massive ecosystem with frameworks like Spring and Hibernate that make building complex applications easier. But Java has its downsides as well. One common complaint is verbosity. Java requires a lot of boilerplate code even for simple tasks, which can make development feel slower. Performance-wise, Java is faster than interpreted languages, but still slower than compiled languages like C++ due to Java virtual machine overhead. Another issue is that Java can feel outdated compared to newer languages with modern syntax. Despite these criticisms, Java remains one of the most widely used programming languages, especially in enterprise environments. JavaScript. JavaScript was created in just 10 days in 1995 by Brendan Eich while working at Netscape. Originally designed to add interactivity to web pages, JavaScript has grown far beyond its original purpose. Today, it's the only programming language that runs natively in web browsers, making it essential for front-end web development. But with Node.js, it can now run on servers as well. What makes JavaScript powerful is its ubiquity. Every modern website uses JavaScript to create interactive elements like drop-down menus, image sliders, and form validation. Frameworks like React, Angular, and Vue have transformed JavaScript into a tool for building entire web applications. On the back end, Node.js allows developers to use JavaScript for server-side programming, meaning you can build both front-end and back-end using the same language. However, JavaScript has its problems. Because it was created so quickly, it has many quirks and inconsistencies that confuse developers. Type coercion, asynchronous behavior, and the "this" keyword are common sources of bugs. JavaScript also lacks strong typing by default, which can lead to runtime errors, though TypeScript has emerged as a solution. The JavaScript ecosystem also changes rapidly, with new frameworks appearing constantly, which can be overwhelming. But despite these challenges, JavaScript remains the backbone of modern web development. HTML and CSS. HTML and CSS are not technically programming languages, but they're essential for building websites. HTML, which stands for Hypertext Markup Language, was created in 1991 by Tim Berners-Lee. HTML provides the structure of a web page, defining elements like headings, paragraphs, images, and links. CSS, or Cascading Style Sheets, was introduced in 1996 to control the visual appearance of websites, including colors, fonts, layouts, and animations. What makes HTML and CSS powerful is that they work together to create the foundation of every website. HTML defines what content appears on a page, while CSS determines how that content looks. Modern CSS has features like Flexbox and Grid, making it easier to create responsive designs that adapt to different screen sizes. CSS animations and transitions also allow developers to add visual effects without needing JavaScript. However, HTML and CSS have limitations. Since they're not programming languages, they can't handle logic or interactivity on their own. For dynamic features, you need JavaScript or a back-end language. CSS can also be frustrating, especially when dealing with browser compatibility issues or complex layouts. Additionally, maintaining large CSS files can become messy without proper organization. But despite these limitations, HTML and CSS remain the essential building blocks of the web. SQL. SQL, which stands for Structured Query Language, was developed in the 1970s by IBM researchers. It was designed to manage and manipulate data stored in relational databases. Unlike other programming languages, SQL is specifically built for working with databases, allowing users to store, retrieve, update, and delete data efficiently. Today, SQL is the standard language for database management, used by almost every company that deals with data. What makes SQL powerful is its simplicity and effectiveness. With just a few lines of SQL code, you can query millions of records, filter data, join multiple tables, and generate reports. SQL is used everywhere, from small business websites to massive systems like banking applications and social media networks. Popular database systems like MySQL, PostgreSQL, and Oracle all use SQL as their primary language. However, SQL has its challenges. Writing complex queries with multiple joins and subqueries can become difficult and hard to read. Performance issues can arise when dealing with poorly optimized queries or databases with millions of records. Another limitation is that SQL is designed for structured data in tables, so it doesn't work well with unstructured data like images or videos. This has led to the rise of NoSQL databases like MongoDB. But despite these drawbacks, SQL remains the backbone of data management and is essential for any developer working with databases. Rust. Rust is one of the newest languages on this list. First released in 2010 by Mozilla Research. It was created by Graydon Hoare, who wanted to build a language that offered the performance of C and C++, but with modern safety features. Rust focuses heavily on memory safety, preventing common bugs like null pointer dereferences without needing a garbage collector. This unique approach has made Rust extremely popular among system programmers. What makes Rust stand out is its combination of speed and safety. Rust is as fast as C and C++, making it ideal for performance-critical applications like operating systems and game engines. But unlike C and C++, Rust's ownership system ensures memory safety at compile time, meaning many bugs are caught before the code even runs. Companies like Microsoft, Amazon, and Dropbox have adopted Rust for critical infrastructure, and the language has been voted the most loved programming language in developer surveys for several years. However, Rust has a steep learning curve. Its ownership and borrowing system, while powerful, can be confusing for newcomers, especially those coming from languages with automatic memory management. Compilation times can also be slower due to Rust's extensive compile time checks. Additionally, Rust's ecosystem is still growing, so it doesn't have as many libraries as more established languages. But despite these challenges, Rust represents the future of systems programming, offering a safer and modern alternative to C and C++. Subscribe, kiddies. See you in the next one.